Hi, I am Mr. Crocker, and today we are going to be talking about prime numbers, prime and composite. So we've already hit on this with our lessons on factors and multiples. If a number only has one and itself as factors, so for example, the number 5, the only way to multiply and make 5 is 1 times 5. There's not another way. So the only factors that 5 has are 1 and itself, 5, 1 and 5. It only has 2 factors. That makes it a prime number, okay? And there are quite a few numbers like this. 7, the only way to multiply and make 7, 7 times 1. There's not another way, okay? So its only 2 factors are 7 and 1. 11, 11 times 1 is the only way. Those are prime numbers. All the other numbers are composite. Okay, so it's kind of like vowels in the alphabet. You know, A, E, I, O, U. Those are vowels. Everything else is a consonant. The numbers where you can only make them one way, those are prime. Everything else is composite. Okay, so the way that I like to teach this and show what prime is to go through a 100 chart. My chart actually only goes, well, you can see to about 60. So we're going to go to 60. Okay, and what I'm going to do is I'm going to count by each number and mark it. Okay, so that'll show you which numbers have which factors. So here we go. Look, I'm going to start with purple, and this is for 2. Okay, so purple equals 2. So I'm just going to count by 2s. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. Makes a pretty clear pattern, right? 52, 54, 56, 58, 60. Okay, so those are multiples of 2. I counted by 2, so all of those numbers are multiples of 2, but we can also say that 2 is a factor of all of those numbers. So any number I marked, 34. 17 times 2 is 34, okay? So we know, except for 2 itself, 2 is prime. The rest of these numbers are all composite because they have 2 as a factor, okay? So let's do another. So now we're going to find multiples of 3. Starting with 3. 3 plus 3 is 6. And so you can see it's like 1, 2, 3. Mark that one. 1, 2, 3. Yeah, 3 will go into 12. 15 plus 3, 18 plus 3, 21. 4, 27, 30. 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, 66, 69. Okay, I know you couldn't see those 60s. I should have stopped. But, okay, all of those numbers that have a green line through them are multiples of 3. If I count by 3, I'll hit those numbers. We can also say that all of those numbers have 3 as a factor. So 27, where did you go? 27 kind of sounds like it would be a prime number, right? It's odd. It's not easy to think what goes into 27, but 3 goes into it. So it's a composite number, okay? Okay, we're going to keep going on. Force equals orange, okay? So here we go. Starting at 4. 4 plus 4 is 8. Plus 4 more is 12. 16. 20. 24. 28. 32. 36. 40. 44. 48. 52. 56. 60. Okay, so you might be able to see a little pattern going on with the 4s too. First of all the 4s were already marked by 2s, right? All the multiples of 4 are also on that list of multiples of 2. And all the numbers we marked with orange are divisible by 4. They have 4 as a factor. So 36. 9 times 4 is 36. 4 is a factor of 36. So that's a composite number. You can see 36 is a very composite number. It has 3 stripes in it already. Okay. 5s. So 5 is blue. Okay, so we start with 5. 5, 10. Counting by 5s is easy. Okay, so that shows you that if a number ends in 5 or 0, it can't be prime because 5 will go into that number, right? So like 55 might sound like it might be a prime number, kind of one of those weird sounding numbers. Probably not much goes into it, but 5 goes into it, 5 times 11. So 5 and 11 are factors of 55. 55 is a multiple of 5. If I count by 5s, I will say 55 eventually. Okay? Okay. 6s. Okay, here we go. 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. Okay. So now we're starting to see some numbers are getting hit a lot, some numbers are just not getting hit. Okay, so we've done all the way up to 6. All those numbers that got a pink stripe were multiples of 6. If they have a pink stripe, 6 is a factor of that number. Okay? 7. Okay, 7, 14, 21, plus 7 more is 28, plus 7 more is 35, plus 7 more, 42, 49, 56, and then the next one would be 63. Okay, which you can't see. Now, I could go through and do 8s, but you know what? All the multiples of 8 are already marked because I've done 2 and 4. Okay, same thing with 9s. I could go through and do 9s. They're already marked because I did 3s. Okay. And what I want to show you here is which numbers are prime, because the prime ones are the ones that are not getting marked. Okay, so what I need to skip ahead to 11. Okay, 11, 22, 33, 44, 55, 66. Actually, that didn't mark any new numbers. Okay, so now the ones that are left behind, those are prime. Actually, if they have one stripe only, then it's their own number. Like for example, 2. Okay, 2 is prime. It got marked because of 2. So 2 is prime. 3 is prime. 5 is prime. It got marked because of 5. 7 is prime. It only got marked because of 7. Okay. Now the prime numbers will have nothing. So 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59. Those are prime numbers. They are numbers that do not have factors outside of 1 and themselves. They're also not a multiple of any of these numbers. These smaller numbers, 2, 3, 4, 5, 6, 7, they won't go into it evenly. Might be one off. Okay, so you're going to do this exact same thing. I'm going to show you. I'm going to give you on Seesaw a board just like this, and I want you to mark it just like I did and circle the numbers that don't get marks, except for those ones in the first row that get marked because of themselves, like 2, 3, 5, and 7. Okay?